Window functions, or sometimes we call them analytical functions. They are very important functions in SQL. Everyone must know them, especially if you are doing data analysis. Each time I write SQL script in order to do data analytics, I end up using them. So as usual, we're gonna go and now understand the concept behind them, and then we're gonna start practicing. So let's go. Okay guys, so now let's start with the first question. What are SQL window functions? They are functions that allows you to do calculations like aggregations, but on top of subset of data without losing the level of details of the rows. So it is something very similar to the group by, but here we have special case. You don't lose the level of details. So now in order to understand the definition, let's have a very simple example. Okay, so now let's understand how SQL works with the group by clause. Let's say that we have the very simple example. We have 4 orders, 2 orders for the caps and 2 orders for the gloves. And let's say that I would like to see the total sales for each product. So now if we decided to use the group by, what SQL gonna do? Gonna take the first 2 orders for the caps and put it in one row. So in the output, we're gonna have only one row for the caps with the total sales of 40. And the same thing gonna happen for the gloves. So we're gonna take the 2 rows of the gloves from the input, and in the output, we're gonna have only one row for the gloves. So that means the number of rows is gonna be depending on the number of products we have on our data. We have 2 products, we get 2 rows. So that means SQL is really like smashing or squeezing the results in the output. And this is exactly what the group by does to our data. It aggregates the rows, aggregate the data into different level of details. So now on the left side, we see 4 rows. On the right side, we have 2 rows, and with that we are losing some details in the results, but still we have solved the tasks. So now let's see what's gonna happen if you use a window function in SQL. Okay, so now we have the same data and as well the same task. We have to find the total sales for each product. Now if you use a window function, SQL gonna do the following. It's gonna go and execute each rows individually from each others. So what's gonna happen? It starts with the first row, the order ID 1. In the output, we're gonna get as well the same stuff, the order ID 1, the same row, but we will get the total sales for the caps. So here the total sales is gonna be 10 plus 30, we will get 40. Then it's gonna jump to the second row and it's gonna process it as well. So in the output, we will get the order ID 2, the product caps, and as well we have the same aggregations since we are talking about the same product. So we will get 40. Then it's gonna go to the third order, and here we have the gloves. So in the output, again, we have the order ID 3, the product gloves, and the total sales this time gonna be 5 plus 20, so we'll get 25. Then it goes to the last row, to the order ID number 4. In the output, we're gonna get 4 gloves and as well 25. So now we can notice that if you use the window function, you will not lose the level of details of your data. So we are doing something called row level calculations. So if in input data we have 4 orders, in the output we're gonna get 4 orders, and as well we will get our aggregations correctly. So now if you compare both of the methods side by side, we can see that we are solving the same task. So we are finding the total sales for each product, but with the group by, we are smashing, squeezing the results from 4 orders into 2 rows, 1 row for each order. So that means with the group by, the granularity is changing, right? In the input, the order ID is controlling the level of details, but in the output of the group by, the product is controlling the level of details. So we have different granularity. But in the other hand, with the window functions, we are still able to do aggregations, but we are not losing the level of details. So the granularity of the input gonna be the same like the output in the results. So this is exactly the main difference between the group by and the window function. If you want just to do simple aggregations, then go with the group by. But if you care about the level of details and you need to add more details to your results, then you can go with the window function where you can do aggregations plus having more details. And now if you go and compare the functions between the window and the group by, we can find that both of them has exactly the same functions for the aggregations. So we have the count, sum, average, min, max. And here comes another difference between the window and the group by. The group by has only the aggregate functions, so that's it. But in the window functions, we have way more functions to use for analytics. So for example, we have the ranking functions, and we have here another group of functions for the value, or we call it analytical functions. So that means in the SQL window, we have a lot of functions. We can cover a lot of analytical use cases and advanced complex stuff. But with the group by, we have only the aggregate functions only for simple use cases. So this is another difference between the group by and the window. Group by, use it if you have simple analysis, simple aggregations. Window functions, we're going to use it for more advanced data analysis where we're going to cover a lot of use cases. Alright guys, so now we're going to have a few tasks in order to understand one thing. Why do we need SQL window functions, and why in some scenarios group by is not enough and we have to use SQL window functions. So let's go. Alright, so let's start with very simple task. It's gonna say find the total sales across all orders. So we need one value, the total sales. Let's see how we can do that. First, make sure that you are using the database. So use sales database in case you have closed the clients, so that we don't get any errors. So now we're gonna start with the first thing. We're gonna go and select the sales. You're gonna find it in the table sales orders. So now let's just query the data, and as you can see we have 10 orders with 10 sales. We didn't aggregate anything yet, so we have the raw data now. So now in order to solve the task, we're gonna use the function sum. So sum of sales, and we're gonna give it new name, total sales. We don't have to use any group by because we don't have to group up anything. So that's it. Let's go and execute that. And as you can see, SQL gonna return one value, 380. This is the total sales that we have inside our data, and this is the highest level of aggregations. So with that, we have solved the task. We have the total sales across all orders. We don't have to group up anything. Let's move to the next example. Let's say that in the next task, this time we want to find the total sales, but for each product. So not for the all orders. For each product, we want to find the total sales. So this time we don't need only one value, we need one value for each product. In order to do that, now we're gonna go and use the group by function, and we're gonna group up by the product ID. And group up needs as well the dimension in the selection. So I'm gonna do it like this. So that's it. Let's go and execute the query. Now, as you can see in the results, we don't have one value. We don't have the highest aggregations. This time we are drilling down to the next level of details. So the level of details here is the product ID. We have one row for each product. So for the first product, we have 140, the next one 105, and so on. So as you can see, we are now splitting the data at the level of product ID. And we went from 10 orders. Now in the results we have 4 orders, and that's because we have 4 products. So the number of rows at the output gonna be defined by the dimension, the product ID. And with that, we have solved the task. We have the total sales for each product. All right, guys, so let's keep progressing in our examples. Now, the next one gonna be a little bit advanced, where we have the same aggregation, find the total sales for each product, additionally provide details such order ID and the order date. So now, as you can see, we have already solved the first part. We are finding the total sales for each product. Now, we just have to add some additional informations like the order ID and the order date. So let's go over here and just add it in our select. So order ID, and let's have the order date. So let's go and execute that. Just gonna make it a little bit bigger. So let's go. But now, as you can see, SQL will not be happy, gonna throw an error and says the stuff that you are adding to your select are not included in the group by. So as you can see in the group by, we have only one dimension or one field called the product ID, but in our selection we have 3 dimensions: the order ID, the order date, and the product ID. So there is no matching between the select and group by, and SQL will not allow it. And now you might say, you know what, let's add everything to the group by. So with that, we're gonna get our aggregation, and as well we're gonna get our details. So let's try that. I'm just gonna zoom out a little bit, and instead of having the product ID, let's add everything. So the order ID, order date, and the product ID. So now we have matching, and SQL should not throw any error. Let's go and execute it. So now let's check whether we have solved the task. The task has 2 parts, right? We have to do the aggregations and to provide details. So as you can see, we have solved the second part. We have the details, order ID and order date, but now the first part, finding the total sales for each product, is destroyed because if you check the results, we have the product ID 101. It has the total sales of 10, but in the third order, we have it as a 20 for the same product. So actually the data is not aggregated, and that's because we are aggregating at different levels, and we have included way more stuff that we don't need for the aggregations. We are aggregating at the order ID level. So as you can see now, we are hitting the limits of group by. We cannot provide aggregations and as well provide additional informations from our data. You have to pick one. That's why we have to go to the second option where we can use the window functions. So let's do that. I'm just gonna get rid of the group by part and as well all the fields. Let's back to the root. So now we have the sum of sales, and if execute this, I'm going to get one value. So we are at the highest level of aggregations. So now we need to use the window function. I'm just going to remove the name, and now we're going to tell SQL this is a window functions. Using over after the aggregations or the functions tells SQL we are talking about window functions. So let's just execute it like this, and with that we got 10 rows, and that's because we have 10 orders, and for each row we have exactly the same value. So we have the total sales of all orders for each row. So as you can see, SQL understands this is a window function, and SQL should not like group all the data in one row. It should keep exactly the same rows or same number of rows like the input. So with that we have the window function, but we have to split the data by the products. So now we're going to use the keyword partition by. It's like the group by but another wording. Products ID, the same dimension. So with that we have the total sales by products as a name. So let's go and execute this. So now as you can see in the output, we still have the same number of rows. We have 10 orders, we have 10 rows, but the result did change because now we are aggregating the data at the level of product ID. In order to understand the results, we have to add more informations to our select. So now let's add the same dimension. It's going to be the product ID. I'm just going to add it at the front over here. So let's select, and as you can see, now it makes more sense. We have those products and they have always the exact same sales, and as well for the next product and so on. And now here comes the magic of the window function. We can add more information to our select statement without having any errors. So now we need additional information like the order ID. So we can go over here and say order ID, order date, any type of column, you can add it to your select, and let's go and execute. So as you can see, now we got the result, even though that those 3 dimensions in the select are not part of the window aggregation. So with that, we have solved the tasks. We have additional informations, we have the order ID, the order date, and as well the first part of the task to find the total sales for each product. So each of those values are the total sales for each product, and with that we have solved the tasks. And this is exactly why we need window functions. In real projects, things get really complicated. You are doing different tasks in one query. So you are doing aggregations, you are doing some other stuff. So just focusing on the aggregations is not going to be enough. You have always to add additional information to your query. So as you can see, we use group by to do simple analysis, but as things get complicated in the analytics, we use the window functions in order to show the aggregations and as well add additional informations. So as you can see, we use group by to do simple analysis, but as things get complicated in the analytics, we use the window functions in order to show the aggregations and as well add additional informations. Alright everyone, so now we're gonna go and deep dive into the syntax of the SQL window functions. We're gonna cover everything, each part of the syntax, for you to understand how to use them. So let's go. Alright, so let's start first by understanding the basic components or the basic parts of each window syntax. Mainly we have 2 parts. The first part gonna be the window function. We have like sum, average, and so on. The second main part is going to be the over clause. And inside the over clause, we have 3 different parts. The first one is going to be the partition clause, the second order clause, and the last one we have the frame clause. And those are all components that you can use inside the window function. So 2 main parts, window function and the over clause, and inside the over we have partition, order, and frame. Let's go more in details. So for example, we have the following window function. So as you can see, we have a lot of stuff going on here. We're gonna understand them step by step, component by component. Let's start from the left. From the first one. So what do we have over here? We have a function, window function. So what is a window function? Like here we have the average. It's like any other function in SQL. You can use it in order to do calculations on top of the window. So the first thing to do or to define in a window is to define the function of the window. And as we learned before, we have a long list of many window functions available in SQL, and we group them into 3 groups. The first one, we have the aggregate functions. So we have the count, sum, average, max, min. All those functions, we have them as well for the group by. So those are used for the aggregations. The second group of functions, we have the ranking functions. So we have the row number, rank, entile, and so on. So we can use those groups in order to give a rank for our data. The last group, we call it value or sometimes analytics functions. So here we have very important functions like the lead, lag, first value, and the last value in order to access a specific value. And of course, we're going to go and learn all of them one by one, understanding the concepts, some examples, and as well for you to understand when to use them for data analysis. Alright, so now let's keep moving, understanding the other parts of the window syntax. Now, inside the function average, we have here a field name or column name called sales. This called a function expression. It's like a value, a parameter or argument that we can pass it to the function. And here we can use multiple different stuff. For example, depend of the function, of course. So here it could be empty, like here in the ranking, it doesn't allow to use an expression, so it should be always empty. Or we can use a column, like in the example, we use the sales. So we use the column name as an argument or an expression. For the average, we are finding the average of sales, or we could use a number. So here in the entile, we are allowed only to use numbers. Or we could have multiple stuff. For example, in the lead, we can have sales, then numbers, and so on. So things get complicated, don't worry about it. I'm going to explain that. So here we have multiple stuff, or we can have a whole conditional logic. So for example, here we have the case when, so on, inside the sum. So the whole thing over here called an expression for the sum. So as you can see, we can build here a complex logic, and the output of this logic can be passed to the function sum. So that means as an expression for the function, we can use different stuff. Of course, depends whether the function allows it or not. Alright, so now let's have a quick overview in order to understand which data types are allowed in the expressions for those functions. Let's see the aggregate functions. As you can see, the count function accepts any data type, but the others like the sum, average, min, max, they allow only numerical data types. Alright, so now let's move to the rank function. The expressions, it's really pretty easy. It should be empty. It doesn't allow any argument or anything inside those functions. So as you can see, all of them are empty, but only one that accepts numerical values, which is the entile. You have to define a numeric value. And now moving on to the last type, we have the value functions. They accept any data types inside the expressions. So as you can see, each function has its own specifications, and you have to be careful which data type you are using in the expressions. Okay, so now let's keep moving to the next one. We have a very important part in the window syntax. So far, what do we have? We have a function, we have an expression. It's like usual stuff. We have done that before using the group by. Now we have to tell SQL that we are dealing with the window function. It's not a normal one. In order to do that, we have to specify the keyword over. So the second main part in the syntax is the over clause, and we use it in order to define a window. And inside it we can define multiple stuff like the partition by, the order by, the frame, but all those stuff are optional. We can skip it and leave it empty. So the main task of the over, it tells first SQL we are dealing with the window function here, and as well you can use it in order to define a window of your data. So now we're going to go and cover everything inside the over clause, and we're going to start with the first one, the partition by. Alright, so now we're going to learn how to define a window inside the over clause. The first part that we can define is the partition by. So for example, here we have partition by category. We have to define the dimension. It's very similar to the group by, another wording. So the first part is going to be the partition clause. What it's going to do, it's going to divide the entire data sets into groups, or you can call it windows partitions. So here we tell SQL how to divide our data. And here we have two options. Let me just show you. So if we don't use anything, so we have it empty, you see over and partition by is not used, what can happen? SQL gonna use the entire data in order to do the calculations. So the whole data, the entire data gonna be counted as one window. So we are telling SQL, don't divide anything, leave it as it is. The second option that we have is to divide the data by partition by. So we define the window like this, partition by products, for example. So SQL gonna go and divide the entire data into different windows. For example, here, 2 windows. And here this time the calculation, the sum of sales, will not apply on the entire data set. This time it's going to be applied on the different windows individually. So we're going to find the sum of sales for window 1 separately from the total sales of window 2. Alright, so now we have this very simple example. We have here 3 fields, the month, product, sales. They are really easy informations. And now we have the following SQL window function. So we have sum of sales And inside the over clause, we are not using anything. So we are not using partition by. So how is SQL gonna define the window now? SQL gonna say, okay, I don't have to divide anything. The entire data set is one window. So SQL gonna go over here and say, the whole thing is one window. So there is no partitions, there is nothing. We have only one window. So the entire data gonna be aggregated. So this is what happens if you don't use partition by and you leave the over clause empty. The entire data is one window. All right, so now let's move to the next example. We don't want to have only one window. We would like to have multiple windows. So we have to divide the data by something. So in the over clause, we're gonna define the window like the following: partition by month. So it's not empty. We are now dividing the data by the field month. So the values inside this column gonna divide the data sets. So here we have 2 months, January and February. So what's gonna do, SQL gonna go and divide the data into 2 sets. The first window gonna be this one of January. So we have the first window, gonna make it smaller. And the second window gonna be the February. So it's gonna be 2 windows inside our data, and the calculation gonna be happening on each window separately. So here, as you can see, we are using the month in order to divide our data sets into 2 windows, one window for the January and another window for the February. So now let's have a quick overview about the options that we have with the partition by. The first option, as we learned, we can just skip it. So without partition by, for example here, total sales across all rows, and here we don't define anything inside the SQL. The second option, we can use one field, one column, for example, partition by product. So we are using one dimension, but we can go and mix stuff. We can use multiple columns or multiple dimensions in the partition by. For example here, partition by product and order status. So here with the partition by, we can define a list of dimensions that could be used in order to divide our data. So in this example, we are saying find the total sales for each combination of products and order status. So those are the different options on how to work with the partition by. So now let's have this overview again. For all functions, the partition by for all those functions is optional. So if you don't use the partition by in all those functions, you will not get any errors. So now let's go back to SQL in order to start practicing with this clause. Okay, so now we have the following task: find the total sales across all orders, and we have to provide additional informations like the order ID and the order date. So let's go and solve it step by step. First, I would like to provide the details. So I'm going to select the order ID and the order dates from the table sales orders. And next we're going to work with the aggregations. So we need to find the total sales across all orders. Again, since we have here details and aggregations, we cannot use group by, we have to use the window function. So we're going to go use the function sum for sales, and now we have to tell SQL we are working with window functions. That's why we're going to use the over clause. And now the next step, we have to think about defining the window. So let's check the task. It says total sales across all orders. So that means we don't have to partition or divide the data sets into like chunks or partitions. We have to leave it as it is, like the whole data gonna be one window. And that's why we don't use partition by inside the definition. We're gonna leave it empty. Let's go now and give it a name. It's gonna be the total sales. Let's go and execute this. And now as the results, as you can see, we have all the orders, all the details, and as well we have the total sales across all orders. So with that, we have solved the tasks. We have the total sales and as well some details about the order. All right, so now let's move to the next task. It's going to be very similar. So it says find the total sales for each product, and we have to provide additional informations like the order ID and the order date. So it's going to be very similar task, but this time we have to divide the entire data into windows. And that's going to be by the product, since we are saying total sales for each product. So this time we have to go and divide the data. So we're going to define the window like this, partition by, and we can use the dimension product ID. Let's go and execute this. So now you can see in the total sales, we don't have anymore the total sales of the whole data, but they are divided. But in order to understand the results, let's go and include the product ID in the results. So product ID and execute. So now by looking to the results, you can see that the data is divided into 4 windows. Let's see them. It's going to be by the product ID. So this dimension going to be controlling the partition. So the first window going to be the product ID 101. So we have the total sales for this product 140. And the next window going to be 102. The third one 104. And the last window, it's going to be only one row, the 105, and the total sales of 60. So with that, we have solved the task. We have the total sales for each product, and as well we have some details. Now I would like to show you the dynamic of the window function. We can add multiple aggregations on multiple levels. Let me show you what I mean. Let's say we stay with the same example, but we're gonna find the total sales across all orders and as well the total sales for each product. So what we can do the window functions on different levels by, for example, here removing the whole definition. So here we have the total sales for the entire data for the first task, and the next one gonna be the total sales but divided by the product ID. Let's here rename it by product. Let's go and execute this. And now, you know what? I'm going to go and add the sales as well, just to explain the flexibility of the window function. So let's go add the sales and execute it again. And now by looking to the results, you can see we have the sales informations 3 times, but with different granularities. The first sales, the sales itself without any aggregations, it is the highest level of details of the sales, and we're going to have the sales for each order. The next one, the total sales with the window function, here we have the highest level of aggregations. So we have the total sales of all orders. And the last one, the total sales by product, it's something like in the middle. We are aggregating on a window, and the window gonna be the product ID. So as you can see, we have different granularities of the aggregations, and this is exactly the flexibility that we have with the window function. We can do all those stuff in one query. Okay, so now let's keep moving and adding stuff to our task. It's gonna say find the total sales for each combination of the products and the order status. So this time we have to divide the data not only by the product, but as well with another dimension, the order status. So now let's see how we can do that. I'm gonna just show the dimension order status and the results, and we're gonna add the following thing. So sum sales over, since it's a window function, and let's go now and define the window partition by. So we have again the product ID, but not only this dimension, as well the order status. And let's go and call it sales by products and status. Let me just rename those stuff. Okay, so let's go and execute. All right, so now let's check the results. It is the last aggregation over here, and as you can see here, the aggregation has different granularities as the previous one, and we have more details. This time we are splitting the data by 2 dimensions. So the first window gonna be the product ID with the order status. It's gonna be only those 2 rows. So we have the order ID 101 and the order status delivered. So the total sales of this gonna be 10 plus 20, and we're gonna have 30. The next window gonna be the same product but with different status. So it's gonna be the 101 shipped, and we're gonna go and summarize those 2 values, and we're gonna have 110. The next product and order status gonna be the 102, and we have it only once. So 102 delivered, it's only once, so it's gonna be the same value. The next partition or window, it's gonna be 2 rows, 102 with the shipped, it's gonna be those 2 things, 60 plus 15, we're gonna get 75. So as you can see here, the product ID and the order status, they are controlling how many windows we're gonna get. So we get here around like 6 windows. With the product ID, we got only 4 windows, and without using anything inside the over clause, we will get only 1 window. So this is how the partition by works. Alright, so that was the first part of the window definition within the over clause. Let's move to the next part. We have the order by. For example, we can use order by, order date. It's just a field. So the order clause is very important in order to sort your data within a window. So the order by is very important as well for many functions. So by just checking the overview over here, for the aggregate functions, it is optional. So you could just leave it or add it. But for the rank function and as well for the value functions, they are a must. So if you want to use those functions, you must use the order clause. because it makes no sense, for example, if you are ranking the data without sorting your data first. Okay guys, so now back to our very simple example, and we have the following query. So the function this time gonna be rank, so we have to rank the data, and the definition of the window gonna be partition by month. So that means we divide the data by the months, so we have it over here, and then the second part gonna be order by sales descending. So we have to sort each window by descending order. That means we start with the highest value and we end up by the lowest value. So let's see how SQL gonna go and execute this. So first, partition by month. So it's gonna divide the data into two partitions because we have two values by the month. So let's see how this is gonna look like. So one window for January and another window for February. Alright, so now SQL gonna go to the second part and execute order by sales descending. So what's gonna happen, SQL gonna go for each window separately and start sorting the data from the highest to the lowest without checking the other window. So in those three values, the highest one is this one. So it's gonna be on top. Let me just sort it. This is gonna be the lowest, you're gonna be in the middle. So SQL gonna sort this window separately from the next one. And then once it's done, it's gonna go to the second one. So the highest value gonna be this one, you are the lowest. Let me just do it like this. So SQL gonna sort it like this. The highest one is 70, the next one is 40, and the last one is 5. So with that, SQL done with the definition of the window. So it's splitted by the month and each window is sorted by the sales. The next step, SQL gonna go and rank those values. So it's really simple. In the outputs, it's gonna rank the data like this. So the first one gonna be this value, the next one gonna be 2, and the third one gonna be 3. So as you can see, SQL is sorting only this window, and it's gonna go and repeat the same stuff for the second window. So each rank is separately from the others. So as you can see, it's very simple. This is how SQL executes partition by together with the order by for the rank function. Alright, so now let's have a quick task for the order by. It says rank each order based on their sales from the highest to the lowest. And we have to provide additional informations like order ID and order date. So let's see how we can write the query. So we have the basic stuff, order ID, order date, and the sales. And now we're going to go and rank the data using window function. So we're going to use the function rank, and then we're going to tell SQL this is a window function, and inside it we have now to provide the definition of the window. So now by checking the task, you can see that we don't have to divide the data, so we don't have to use partition by, we have just to use rank, and with rank we have to use the order by, it is must. So we're going to use order by, the field going to be the sales, and from the highest to the lowest. So let's just call it rank sales. And let's go and execute this. And as you can see, our results going to be sorted from the highest to the lowest. So you can see the sales 90 at the top and the lowest going to be the 10. And as well, we have a rank. So for the top rank, it's going to be 1 and the lowest rank going to be 10. So as you can see, we just quickly create a rank in SQL. It's very simple. The whole thing is one window since we are not using partition by. And of course, if you want to have ascending, so from the lowest to the highest, you can just remove it because optionally going to be ascending. So let's go and execute the query. So now we can see the orders are sorted the way around. So we start with the lowest and end up with the highest. And of course, you're going to get the same results if you go over here and add ascending. So if we execute, you see we got exactly the same results. So this is how you use the order by inside the window definition. Okay guys, so with that you have covered the second part of the window definition. Now we're gonna go to the last part, to the most advanced part of window. And we have the following stuff. So we have rows unbounded preceding. We call this a frame clause or window frame. So what we are doing over here is that we are defining a subset of rows within each window that is relevant for the calculation. Totally understand if this is confusing at the start or complex. It was for me as well. So what we're going to do, we're going to deep dive into the concept in order to understand how this works, and we're going to do it step by step. So don't worry about it. All right, so now let's understand what is going on with the frame clause from the basics. So now if you do aggregations and you don't use window function, you're going to consider the entire data or rows inside the table. But what we can do, we can go and divide the data using partition by to a window. So for example, here we have window 1 and window 2. Now if you go and do aggregations, all the rows in the window 1 going to be aggregated, and then SQL going to go to the window 2 and aggregate all the rows. What we can do in SQL is that we can say, you know what, I don't want all rows inside the window, I want a subset of rows inside the window. So what we are doing over here is that we have those two windows, but we specify a scope, or we specify subset of data from each window to be involved in the aggregations. And of course, not only aggregations, we can do ranking and other stuff, so I mean calculations. So here, like, we have a window inside a window. So we are defining a scope of rows. Not all rows should be involved in the calculation, but only a specific subset of data. And we can do that using the frame clause. So now again, the partition by, you can use it in order to divide the entire datasets into multiple windows. And now for the frame clause, if you don't want to consider all the rows within each window in the calculation, you want to focus and specify only a subset of data within each window, then you can go and use the frame clause. Alright, so now let's go and understand the syntax of the frame clause. Let's have the following example. We are saying the window function is the average of sales, and then we define the window. So we have the first part, partition by categories, order by order dates, and then we have the frame clause. It's going to be the following: rows between current row and unbounded preceding. This is the frame types, and we have two types. We have the rows and groups. Then we have like between and a range. So the first range gonna be the frame boundary, the lower value. And here it accepts three types of keywords, like the current row, or a number of preceding, or the unbounded preceding. And then we have another frame boundary. It's going to be the higher values, and it accepts the following stuff. We can use the current row, in following, or unbounded following. So as you can see, we are defining like boundary or a range from low value to high value. So now we have some rules. We cannot use the frame clause without order by. So order by must be exist in the definition in order to use frame clause. And the second rule, it says lower boundary must be before the higher boundary. So always we start with the lower boundary and we end up having the higher boundary. You cannot switch that. Okay, so now we have a very simple example. We have the month and the sales and the following query. Sum of sales, this is the window function, and the definition of the window going to be order by month. We are not using partition by just in order to make our life easier. And the frame clause is going to be defined like this: rows between current row and the two following. So now let's see how SQL can execute this. The first definition, order by month, as you can see, the months are sorted already. So now SQL gonna work with the frame definition, current row, and the two following. So SQL gonna process this row by row. So it's gonna start with the first row, and it's gonna be our current row, as here in the SQL. So this is our current row, and we say the range until two rows, two following rows. So it's gonna be February and March. So that means the pointer gonna be over here for the two following. So with us, we have the frame boundaries, and SQL have the following scope for the first row. So we have 3 rows, and the summarization of those 3 rows gonna be around 70. So we will get for the first row 70 because the scope is not all rows, but only this subset of data. Okay, so with that, SQL is done with the first row. It's gonna jump to the second row. So the pointer gonna be the current row at the February, and the second 2 following gonna be at April. So with that, as you can see, we are sliding down in the subset of data or in the window. And with that, we have a new scope, a new subset, and the summarization of all those values gonna be 45. So that's it. I think you got it already. SQL gonna go to the next one. The pointer gonna be on March, and the 2 following gonna be on June, and it's gonna slide like this. We have those 3 rows in the scope, and the summarization of that's gonna be 105. So now things get interesting for the next row. So the pointer for the current row gonna be April, but the 2 following gonna be like after the end of the table or something like that. So as we slide down, as you can see, the scope now, or the subset of the frame, gonna be only 2 rows, and the output gonna be 75. And finally, if you go to the last row, it's gonna be the current row, and we're gonna have only 1 row for this subset because the 2 following is just outside of the table. And we're gonna get the same value as the summarization. So as you can see, that's it. It's very simple, right? So the frame, we use it in order to scope which rows are involved in the calculations. So all what you have to do is to define the boundaries of the frame, the lower and the upper boundary. Let's see what other options do we have with the frames. Okay, so here we have the same example, but we redefine the boundaries of the frame like this: rows between current row, this is the first boundary, and unbounded following. This means that we are targeting always the last record in the window or in the table. So unbounded following gonna be always static, and it's gonna be, in this example, pointing to June. And now SQL gonna go row by row, and the current row gonna be like the start January and then February. I'm just gonna take this example. The pointer is on February, and the subsets or the frame gonna be those 4 rows. So it's gonna be February, March, April, June. So it's gonna be 4 rows, and the total aggregation of that's gonna be 115. So you can do it like this, and previously it was like flexible, more flexible. It was 2 following, but this time we have unbounded following. That means always the boundary gonna be the last one. So as we are moving with the records over here, the boundary is gonna be smaller, smaller, and like this. And the last one, they're gonna be both in the same record. So the current record gonna be as well the unbounded following. Okay, let's see the next one. The definition of the window gonna be the following: rows between one preceding and the current row. So here it's the way around. One preceding is lower than the current row. So let's see how SQL gonna execute this. Let's say that we are currently at March. So this is the current row, and we are saying between one preceding. So that means one row before the current row. So the frame gonna be like this. And we have only 2 rows, so the value gonna be the summarization of those 2 rows, and it's gonna be 40. So that means we are always targeting the rows before the current row. Okay, so now let's keep going with the other options in order to understand everything about the frame. So we redefine it like this: rows between unbounded preceding and the current row. So unbounded preceding gonna be the first row in the table or in the window. So it's gonna be static like this. It's gonna be the first one, January. And let's say that we are at this current row in March, so the window or the subset gonna look like this, though 3 rows, and the total of that's gonna be 60. So now as SQL is proceeding to the next one, it's gonna fix the first boundary, so it's gonna be always pointing to January, and the subset gonna be a little bit bigger until we reach the last one, and with that we're gonna have the subsets, the whole rows. So with that we get a really great flexibility on how to define the subset and how the subset is shifting through the window. Okay, so now we are just having fun, so we are just playing around with the boundaries. We don't have always to use the current row. So we can use, for example, here in this definition, rows between one preceding and one following. So we don't include at all the current row in the boundaries. So let's say again, our current row gonna be in March. So one preceding gonna be February, and one following gonna be April. So with that, our frame gonna be those 3 rows, and let me get it like this, and the aggregation of this gonna be around 45. So with that, as you can see, the boundary is gonna be one preceding and one following, so it should not be always the current row. All right, so now I think you already get it. What's gonna be the last option? We're gonna have everything. So the definition of the frame gonna be rows between unbounded preceding and unbounded following. What we're gonna have over here, the unbounded preceding gonna be January, and the unbounded following gonna be June. And now the frame gonna be everything, all the rows, and it doesn't matter where are we with the current row, it's gonna be always a fixed subsets, so it's going to be always everything. So if we are over here or February or March, we're going to be considering all rows, and the total sales of that's going to be 135. So we will get the exact same result for everything for all rows. So with that, I think it's not that complicated, right? We just have to provide the boundaries, and then the calculation going to be depending on the frame, on the subset of data. Okay guys, so now let's go back to SQL and start practicing in order to understand how the frame work. So let's go and define a window like this. So sum of sales, and the window definition like this. We're gonna divide the data by order status, and let's say we're gonna sort it by order date. And let's define a frame like this: rows between current row and 2 following. Let's give it a name, total sales. So let's go and execute it. So now let's look to the data. You see that SQL gonna divide our result into 2 sections, 2 windows, delivered and shipped. And you can see that the data is sorted by the order date. So as you can see over here, for example, on this status delivered, we can see that 1st of January, 10, and so on. And then the third part, we have defined a frame in each window. So for example, let's take the first one. So this is the current row. So we say the frame is between the current row and the 2 following orders. So that means the scope gonna be like this. So 10 plus 20, 25, it's gonna be 55. And now what is interesting as well to check here is the last record of each window. So now let's take this window over here, and the last record gonna be number 7. So this order, and let's say this is the current record. So we said the frame between current record and the 2 following. But since it is the last record of this window, it will not go and consider the next 2 orders because those 2 orders are outside of the window. And that's why we have here 30, and SQL didn't go and summarize all those values. So we have it 30 and there is nothing after that. That's why we will get 30. So as you can see, the frame going to be calculated within one window. So it will not consider anything outside of the window. So this is how the frame works within partitions. So now I would like to show you as well a few stuff about the frames. We can use shortcuts, but we can use them only with the preceding. So for example, let's say I'm going to change the definition like this to precedings and current row. So let's go and execute it and we will get those results. So now if you want to check the results quickly, let's take, for example, this order over here, and we are always summarizing the values of the 2 previous orders. So that means those 3 orders going to be involved in the frame and the output going to be 55. So now there is a shortcut for SQL, but only for the preceding, where we can remove the range. So we can go and remove everything and we can leave it like this. Rows to preceding, and if we go and execute it, we will get exact results. So this is a quick way or a shortcut on how to define a window, but it only works with the preceding. So for example, if I go over here and say, for example, unbounded, it's gonna work. So we will get the results between the unbounded preceding and the current row. But if you go over here and you say, you know what, let's have the unbounded following, SQL gonna say there is an error. And the same thing if you remove the unbounded, let's say for example 1 following, SQL will not like it. So you can use the shortcut only with the preceding. And one last thing about the frames is that there is a default frame. So if you don't use any frame and you use order by, what can happen, SQL gonna use a default frame. So if you check the result, you will notice that for this window over here, those values are not like the whole values of the cells. There is like frame, there is a hidden frame. And the default frame in SQL gonna be like this: rows between unbounded, preceding, and current row. So this is the default frame if you use order by. So now if you go and just execute it, you will see that we will get the exact results. So be careful, once you use order by with the aggregate functions, there will be a hidden frame or a default frame like this between the unbounded preceding and the current row. So that means there are 3 ways in order to do this scenario of framework between unbounded preceding and current row. Either write it like this, or you can go and have a shortcut like this. Let me just execute it. So we'll get the same result, or just remove it completely. We will get as well the same results. Now again, the hidden frame or the default frame is only working with the order by. So if you go, for example, here and remove the order by, let's see the results, the whole window will be aggregated. So again, let me just select it. So you can see that SQL gonna consider all the rows in the aggregations, and we will get the total sales for the whole window. So there will be no frame defined. Only it's going to be present once you use order by. Alright friends, so with the frame clause we have now covered all the components on how to define a window inside an over clause, and with that we have covered everything about the syntax of the window functions. Okay guys, so now we're gonna go and understand the rules, or let's say the limitations of window functions. So let's learn what you are not allowed to do while using window functions. Okay, so the first rule is that you are allowed to use the window function only in the select clause and as well in the order by clause. So here we have again the same example where we're finding the total sales by the order status. So as you can see, we used the window function in the select clause and we didn't get any error, right? So now we can go and use it as well in the order by. So let's say order by, and let's go and copy everything but not the name in the order by. So if I go and execute this, there will be no errors and SQL can allow it. And as you can see, the result didn't change. So let's go and sort it, for example, descending. So I'm gonna write here descending, and let's execute. Now we have the total sales with the highest values, then the lowest values. So having this rule that we can use it only in select and order by, that means we cannot use window functions in order to filter data. So let me show you. For example, instead of order by, let's have where clause, where the total sales, let's say bigger than 100. So let's go and execute this. And as you can see, SQL gonna say, no, you are not allowed to do that. You can do that only for select and order by. So we are not allowed to use it for filtering data using the where clause. And as well, you are not allowed to use it in the group by. So if I go and do a group by, and as well remove the condition over here, so if you execute it, you're going to get the same error. You are not allowed to use the window function in the group by, so only with the order by, or as well in the select clause. Okay, so now to the second rule, you cannot use window functions inside another window function. So that means you cannot go and nest window functions together. Let me show you what I mean with that. So let's remove the group by. Now everything should be working. Let's take and copy the whole window function over here, and let's just nest it. So instead of sales, we're gonna have now window function inside another window function. So as you can see, this is the inner window function, and the rest, the outside, is the outside window function. So if I go and execute this, you will see that SQL gonna tell us you cannot use the window function in the context of another window function. So we cannot do nesting using window functions. So as you can see, this is another limitation for those functions. All right, moving to the third rule, or let's say an info. The window function can be executed after filtering the data with the where clause. Let's have an example. So now let's say that I would like to have the same informations, the total sales for each status, but only for two products, 101 and 102. So let's go and do that. So we're going to use the where clause, and then we're going to say product ID in, we're going to specify 101 and 102. So let's go and execute this. Now you can see we still have two partitions. So one for the delivered and one for the shipped, but the total sales is reduced because we are only focusing on two products and we filtered the whole data sets. So how SQL works, first the where clause is going to be executed, and then the window function is going to be calculated. So that means first filtering and then aggregations. Okay guys, now we're going to move to the last rule, to the most interesting one, and it says the following. You are allowed to use the window function together with the group by clause only if you use the same columns. So let me explain what do I mean, but first some coffee. Let's have the following task, and it says rank the customers based on their total sales. So now it sounds really easy, but if you check it, you have here two calculations. The first one, you have to rank the customers, and the second calculation is an aggregation. You have to find the total sales for each customers. Okay, so now I'm going to show you step by step how I usually solve those tasks. So for now, let's check the total sales. It is an aggregation, right? So we can use the sum function, and this function is available in both group by and as well in the window function. So for now, I'm going to go with the group by, and that's because the task is very simple. We don't have to show any other details, right? So it's all about aggregations. So why not using the group by? And now to the first part where we have to rank the customers, we cannot use the rank function with a group by, right? Group by uses only aggregations. So here we are forced to use the window function. So that means for the rank, I'm going to use window function. For the total sales, I'm going to use a group by. So now let's do it step by step. So first we have to find the total sales for each customer using group by. It's very simple. So I'm just going to remove all those stuff in our select statements. We need the customer ID. And then we don't need a window function over here. And then after the from, we're going to have a group by customer ID. So now I'm just grouping the customers and finding the sum of all sales. Let's go and execute this. So now as you can see in the results, we have 4 customers, and that's why we have 4 rows, and as well we have the total sales. So let's say the half of the tasks is already solved, right? Now what is missing with us? We need a rank. So let's go and build that. The second step, we're going to use the rank function, and we're going to define a window for that. So over, and inside it will not partition the data at all because it's already like grouped up. So what we're going to do, over order by, the rank function always needs an order by. Don't worry about it, we can talk about it later. So now we are ranking the data based on the total sales. That means the sum of sales. So what we're going to do, let's just go and copy this and put it after the order by. And now we have to decide whether ascending or descending. It's going to be descending, so the highest sales first and then the lowest sales. So now as you can see, we have now a rank customers, and we have a window function now together with the group by. So now let's go and execute this and see whether SQL can allow it. So let's run it, and as you can see, SQL runs it, and we will get the rank for each customers. So the customer 3 has the highest total sale, then the customer number 1, and the last one gonna be customer number 2 with the lowest total sales. All right, so we solved the tasks. We have now ranked the customers based on their total sales. So as you can see, SQL allows you to use window function together with the group by, but only with one rule. Anything that you are using inside the window function should be part of the group by. So for example, we fulfill the rule because we are using the sum of sales, and the sum of sales is a part of the group by, right? So now if I go, I just break the rule by not using the sum, just using the sales. So if I just remove the sum and use only the sales, SQL will not allow it because the sales is not part of the group by. So as you can see, SQL is very strict with this. If you want to use everything in one query without using like subqueries and so on, you have to use the exact same columns. So for example, if I go over here, instead of sales, I use the customer ID. So since the customer ID is a part of the group by, SQL can allow it. So be careful using window function together with the group by. As long as you are using the same columns, nothing gonna go wrong, and SQL gonna allow it. Okay, so now I'm just gonna go and fix this, and let's run it. So now as you can see, it's really easy if you follow those steps. First, build the query using group by. So don't you think about the window function, just build the group by. And then the next step, the last one, you go and define and build the window function. So with that, you can solve really nice analytical use cases with a simple one query without having you to build like subqueries and so on. You can go and use group by together with the window functions. All right, guys, so those are the 4 rules for the SQL window functions. Alright friends, so now let's have a quick recap about the SQL window functions. Let's start with the definition. It's gonna go and perform calculations like aggregations on top of subset of data without losing the level of details. So that means we can do aggregations and at the same time we are not losing the details. Now of course there is a lot of similarity between the window function and the group by, but the main difference is that window functions are very powerful and dynamic compared to the group by. We have way more functions than the group by, right? But now if you are doing data analysis and you have an advanced use case, then you have to go and use window function. It's more suitable for complex and advanced data analysis. But in the other hand, if you have a simple question, simple data analysis, then you can go and use the aggregate functions using the group by. And of course you can go and use them in the same query, in the same select. You can go and mix the group by together with the window function with only one rule. You have to use the same columns. And of course the first step is to do the group by, and then later you do the window function in the same query. And now to the next point about the window components. We have 2 main components. The first one is the window function, and the second part is the window definition using the over clause. And inside the over clause we can define 3 things. If you want to divide the data to create windows, you can use the partition by. The second section we have the order by in order to sort your data. And the last part you can go and specify a subset of data like a frame within each window. Now let's move to the last part. We have rules for the SQL window functions. So the first thing is that if you have 2 window functions or multiple window functions, you cannot go and nest them together. You have to go and use multiple subqueries. The next point is that you can use the window function only in the select and the order by clause. So for example, you cannot use the window together with the where clause in order to filter the data. Talking about filtering data, how SQL gonna go and execute the window function? It's always after SQL filter the data. Alright, so those are the basic stuff about the SQL window function. Alright, so with that we have covered the basics about the SQL window functions. What is window functions? Why do we need it? The syntax, the main components. And now moving on to the next one, we're gonna learn how to aggregate your data using the window aggregate functions. Here we have 5 functions, so we can understand the syntax, how it works, the use cases, and everything. If you like this video and you want me to create more content like this, I'm gonna really appreciate it if you support the channel by subscribing, liking, sharing, commenting. All those stuff gonna help the channel with the YouTube algorithm, and as well my content gonna reach the others. So thank you so much for watching, and I will see you in the next tutorial. Bye.